Hello everyone. My name is Rahil Parekh, and the topic that I have chosen for my honors IA is analyzing the performance of stroke prediction using machine learning classification algorithms. The introduction. According to the Center for Disease Control, CDC, strokes are the fifth leading cause for death in the United States of America. A stroke is basically a non-communicable infection that is responsible for around 11% of total deaths. In India, strokes are the fourth highest cause for death. Now, with the advancement in technology, the occurrence of strokes in a person can be predicted using machine learning algorithms. The trained model is subsequently deployed using Flask. The Flask-based web application provides a GUI or a graphical user interface for the user to enter the values for predicting whether a person is likely to have a stroke or not. Now, once the inputs are received by the model, it makes the prediction. The final results are displayed on the website itself for the user to see. The results tell you whether you are susceptible to brain strokes and what the likelihood is of you getting a brain stroke. Now, the literature survey. So the research paper that I am analyzing, it makes use of machine learning algorithms suited for tabular data, such as logistic regression, naive Bayes classifier, KNN, K nearest neighbors, random forest classifier, etc. It outperforms research papers proposing a deep learning approach for stroke prediction on tabular data. Now, ultimately, naive Bayes classifier, it gives you an accuracy of 82%, which is more than that obtained by fully connected dense neural networks that only give you an accuracy of about 75%. Now, this is the system methodology. So the first thing is you collect the data. You collect an appropriate data set from any open source data sets available on Kaggle or GitHub, or you scrape the data set. Then you pre-process the data by handling missing values, imbalance, performing label encoding. Then you train the machine learning algorithms like logistic regression, random forest, naive Bayes. And then you combine these two steps and you create and compare a model. And the best model is the one that you deploy using Flask. So once the data collection step was completed, the data was pre-processed. The pre-processing step included filling in the missing values and label encoding. The next step involved training machine learning algorithms to make the necessary predictions. Once different ML models were created, the one with the best accuracy was selected. Finally, the best model was deployed using Flask. So this is the data used. So the ID column is the first column, which is an integer. Then you have gender, which is male, female, or other. Age, hypertension. It tells you whether the patient has hypertension or not. Heart disease tells you whether the patient has heart disease or not. Is he ever married? What kind of work he does, where he stays, average glucose level, BMI, which stands for body mass index, smoking status, has he formerly smoked, never smoked, does he smoke currently, or is it unknown, and stroke. So this is stroke is basically your label, which is what you are trying to predict, and it is basically a binary value, 0 or 1. Now data pre-processing. So this step is essential in removing unwanted noise and outliers from the data set. So the column ID is dropped because it does not affect the model training. Next, the data set is checked for null values, which are filled if found. Missing values in the column called BMI, body mass index, are filled with the mean of the column data. And next, the categorical variables are label encoded. Now dealing with imbalance data. So as we can see, there is a high class imbalance in the data set with 4,861 rows belonging to class 0, which is no stroke, and only 249 rows belonging to class 1, which is a stroke. So to deal with this, you use a method called undersampling. Basically, in undersampling, you make the class 0 and class 1 have the same number of rows. So in undersampling, you reduce this number 4,861 to 249 and make it equal to the number of rows in class 1. Now the classification algorithms used. So the results for different algorithms are as follows. Logistic regression, you get an accuracy of 78% and an F1 score of 77.6. Decision tree classifiers give you an accuracy of 66 and an F1 score of 77.4, which is a bit lower than that of logistic regression. Random forest classifier gives you an accuracy of 73 and an F1 score of 72.7. KNN, which stands for k-nearest neighbors, it gives you an accuracy of 80% and an F1 score of 80.4%. SVM, which stands for support vector machines, gives you an accuracy of 80% and an F1 score of 81.1%. So the accuracy for SVM and KNN are the same, and the F1 scores are also pretty similar. Now, naive Bayes classifier, it gives you an accuracy of 82% and an F1 score of 82.3%. ROC AUC for naive Bayes classifier. So ROC AUC basically stands for receiver operating characteristics area under the curve for naive Bayes classifier, and you get a value of 0.82, which is pretty high as compared to all the other machine learning models analyzed. Now, the model deployment is done using Flask. So Flask is basically a lightweight web framework that helps you deploy machine learning models and create websites. And the user can input values through the GUI to get the final predictions. So you can input values like gender, hypertension, work type, body mass index, smoking status, and you can get the prediction on whether the person is likely to have a stroke or not. Now, comparing ML models on the basis of accuracy. So the first thing we do is compare them and see how they perform. So naive Bayes has the highest accuracy of 82%, and decision tree classifiers obtain the lowest accuracy of only 66%. Now, comparing ML models on the basis of precision. So precision is true positive upon true positive plus false positive, and naive Bayes has the highest precision of 79.2%. The lowest precision is obtained by random forest classifier, with a value of 72, and logistic regression and decision trees have the same precision of 77.5%. Now, comparing models on the basis of recall. So recall is true positive upon true positive plus false negative. Again, naive Bayes has the highest recall of 85.7%, whereas the lowest recall is obtained by random forest classifier with a value of 73.5%. The recall obtained by logistic regression and decision tree classifier are very similar to one another, with a difference of only 0.1%. And also the values of recall obtained by k-nearest neighbors and support vector machines are also very similar, with a difference of only 0.1%. Next, we compare them on the basis of F1 score. So F1 score is basically the harmonic mean of precision and recall. Harmonic mean is nothing but 2 into precision into recall upon precision plus recall. And naive Bayes has the highest F1 score of 82.3%. And the lowest F1 score is obtained by random forest classifier of 72.7%. So one of the reasons for this could be overfitting, because random forest is generally prone to overfitting on tabular data. So that could be one of the reasons why it does well on the training set but bad on the test set and gives you only a F1 score of only 72.7%. Now, the conclusion. So strokes are a critical medical condition that should be treated before they worsen. Now, building a machine learning model can help in the early prediction of strokes and also reduce the impact in the future. Naive Bayes classifier, it provides the highest accuracy of 82% for the classification task. Now, the accuracy can be further improved by ensembling different machine learning models together. So, ensembling is basically the process of taking multiple models and combining their final predictions. And the final prediction would give you a better accuracy than the predictions of any single model. So ensembling can definitely be used to improve the accuracy, and that is kind of a future work of this research paper as well. So yeah, that's it from my side. Thank you.